Okay, so the next thing to do is rotations. And with a rotation, you can't pick up, just move it anywhere you want, sort of like with a translation, you can't flip it over like a reflection, but it's still like moving the paper. So you just kind of imagine that you put a pin in the center and it'll say about whatever point. So in this case it says about the origin. So that means that you would put the pin in the point 0, 0, and then you can spin the paper any way you want. You just have to keep that pin in the center. Uh, positive, positive degree angles go counterclockwise. And we're only going to deal with positive, but you will in your future, and you could, in theory, rotate, say, negative 60 degrees, and then you'd go clockwise, and you'd end up in the same position as if you went 300 degrees counterclockwise, or the positive position. So if we rotate this 90 degrees, then quadrant 1 moves to quadrant 2, and if you rotate 180 degrees, it would move to quadrant 3, and so forth, and you're just making a copy of the quadrant just spun over, but flipped around. So if I spin this around, imagine it spinning, then I'm going to end up here, and the A, that'll go down to 4, negative 4. So it'll end up looking like this. So C, which was 2 away from this side and 1 away from this side, will be 1 away from this side and 2 away from that side. So this is C prime, and this is B prime, and this is A prime. Because if you just tilt your head to the right, and you'll see what it looks like over there. If I go, so 90-degree rotation, A has gone to negative 4, 2, and B has gone to negative 1, 4, and C has gone to negative 1, 2. And then if I keep going another 90 degrees, then I end up with a copy down here. So it'll be like this. Where this is C prime, because I'm still coming from here, so it's, reusing that letter there. A prime, B prime. So on the 180-degree rotation, A went to negative 2, negative 4. B went to negative 4, negative 1. And C went to negative 2, negative 1. Now if I go one more time around, then I end up this triangle. So this one is B prime, this one is A prime, C prime. So this time A prime is 4, negative 2, and B prime is 1, negative 4, and C prime is 1, negative 2. So if you look at all of the different versions of C, all the different versions of B, all the different versions of A, you see that you have the same numbers repeating. So in A, you've got 2, 4, negative 4, 2, negative 2, negative 4, 4, negative 2. So it's all these 2's and 4's. That's only because we're doing rotations that are multiples of 90 degrees. The one thing that you would preserve all the time, though, is the distance from the center, so in this case, the origin. So you'd always have, basically, if you use the Pythagorean theorem, you do the distance formula from 0, 0. it would always be the same, but not necessarily from the exact same two values. This C could map anywhere in the circle that has these points in it. I'm not going to be able to do a very good circle with this pen, but so something like that. Anywhere along there is where C could land, because it's essentially spinning in a circle around the origin. So if we compare the coordinates of the pre-image with those of the image, a 90-degree rotation, what happened is that the x value went to, well, the x value went to negative y, and the y value went to the x value, if that makes sense. So we take what the y used to be, 4, and we do negative 4, and that's our new x. We take what the x used to be, 2, and that's our new y. In the 180-degree rotation, we went from 2 to negative 2 and 4 to negative 4. So it was just that x went to negative x and y became negative y. For the 270-degree rotation, we did a swap again so that the new x was the old positive y and the new y was negative x. So if we started with xy on a 90-degree rotation, would end up with negative y x. 180 degrees would have negative x, negative y. Just change their sign. And 270, and remember this is counterclockwise, 270, we go to y, negative x. Okay. So we want to rotate the figure ABCD 90 degrees. So this is basically, if you tilt your head to the right and you look at it like it's in quadrant 2, this is what we want to end up with. So if I look at it that way, CD is going from 2 to 4 vertically on 2. So it's going to go from 2 to 4 on negative 2. And then we would go across 3. So I move that. I can also just change all the points like we did before. So A was 2, 5. So now it's negative 5, 2. Based on what we just described. So A prime, B prime, C prime, D prime. Now the question on number 5 is, how many degrees has the image been rotated? Well, for one thing, because all the numbers are staying the same, we have 2, 3, negative 2, negative 3, 7, 3, negative 7, negative 3. We just, on the previous slide, saw that means, actually, that it's 180 degrees counterclockwise, so 180 degree rotation. So if we compare, and you don't even have to really compare that hard, but if we compare the image and pre-image, we want to decide if it's an isometry, and remember, isometry just means that it's the same size. So if I put a pin in the middle of something and I spin it around, I'm not going to change the size of it, you know, as long as it stays on the same sheet of paper, which it is. So it's still an isometry. So now we have translations, reflections, and rotations, and all of those are isometry, which is also known as a rigid transformation. Okay, so here we have a hexagon, and we want to find the image of things rotated around that point 0, which is the center. Well, the thing about a hexagon is that it splits that 360 degrees that you have all the way around into 6 pieces. So each of these is going to be 1/6 of the 360 degrees. So each one's going to be 60 degrees, and hexa always means 6. So these are 6. Regular means they're all equal. All the sides are equal, all the angles are equal. So these are each 60 degrees. So it's a rotation of 60 to get to any one of those little line segments to the next little line segment. So if I want to get from A to B, I have to go 60 degrees. So that's just 60. If I want to go from B to F, I have to go 60 degrees 1, 2, 3, 4 times. So 4 times 60 degrees, 240. If we take point B and we rotate it 120 degrees, that's 2 times 60. So 60, 120, we get to D. If we take this whole line segment here, the whole thing, and we go 300 degrees, so 60, 120, 180, 240, 300, we get here. We need to write that as BC. Even though it's the same line segment, if we wrote CB, writing it BC indicates very clearly that C went to B and D went to C, instead of C going to itself and B and D going to each other, which would be a reflection. Now if we take this whole triangle, FOA, that whole thing, and we rotate it 240 degrees. So we take it and we go 60, 120, 180, 240. It's this triangle. And A went to E, F went to D, O stayed the same. So we would write it as D, O, E. Now it's telling us for sure that these are all squares. And O is the center, and O is the center of this square, so it means if we flip this around in multiples of 90 degrees, we're going to end up with this plus sign still. We want to find the angle of rotation that takes DC to BA. So this to this. So essentially, we want to know this angle here. And that angle is 90 degrees. So 90 degrees. And then what triangle do we get if we move this thing, JEF, around 270 degrees? Because this is kind of basically split in fours here, each of these is 90 degrees. So every time I move 90 degrees, I'll land on one of the other blocks. So we go 90, 180, 270, we land here, and J lands on K, E lands on G, F lands on H, so this is the triangle that we get. So J went to K, E went to G, F went to H. Regular pentagon, so regular still means all the angles are the same, all the lines are the same, O is the center, so each one of these is 360, 1/5 of 360. 1/5 of 360 is 72. So each of these little pieces is 72 degrees. To get from K to M, I go 72 degrees 3 times. So 72 degrees 3 times is 216 degrees. If we start with LO, so we're starting with this line here, and we're going to rotate 216 degrees, which we just discovered is 3 little triangles round. Then we go 1, 2, 3, and we get here in O. And that brings us to compositions of these. So I will stop and start again.